Page 189, question number 6. A 60 kilogram athlete, so we have mass of 60.0 kilograms, jumps vertically upwards from the ground to a height of 0.910 meters. So the height, 0.910 meters. What was the athlete's initial vertical speed? Okay, so we're taking a look at the law of conservation of energy. The sum of the mechanical energy before equals the sum of the mechanical energy afterwards. So what we have is ground level here. We have an athlete. They bent their legs. They're all set to jump. So at this point, they have an unknown velocity, but their height is equal to 0. That athlete is going to jump up into the air. At this point, they're going to have a height of 0.910 meters, and their velocity will be 0. They're going to jump up, come to a halt, and that's where what we're going to use to figure out their velocity at the start. Just going to move this over, make it a little neater. So we know the sum of the mechanical energies at the start equals the sum of the mechanical energies at the top. So our kinetic energy at the bottom plus our gravitational potential energy at the bottom equals our kinetic energy at the top plus our gravitational potential energy at the top. So at the bottom, they have a height of 0, so their gravitational potential energy is 0. And at the top, their kinetic energy is 0. So the kinetic energy at the bottom is going to convert to the gravitational potential energy at the top. So we have the kinetic energy at the bottom, gravitational potential energy at the top. That gives us mv squared over 2 equals mgh. Mass of the athlete doesn't matter because it cancels out. We divide both sides by m. Since we're looking for v, we multiply by 2 and then square root. So v equals 2gh, all square rooted. That's going to give us 2 times 9.81 meters per second squared times our height of 0.910 meters. So square root 2 times 9.81 times 0.91 gives us a value of 4.225423056 meters per second. 3 significant digits in the height, 3 significant digits in the mass. So we get 4.22. The 2 rounds up because of the 5, so we're going to get 4.23 meters per second. And again, with energy, we don't always have to put the direction, but in this case, since we know it, I'm going to put it in. Wouldn't take off marks if we didn't have that. But our direction in this case is up.